this is for the second part of experiment 4. After you've prepared your solution, you're now coming back and you're going to be using it in this part of the lab. So the second part is all about chemical kinetics. So in general, the rate of a chemical reaction depends heavily on the concentration of the reactants. So here's the equation of reactants A and B forming C and D. Capital A, B, and C and D are the chemical substances, and lowercase a, b, c, d are their coefficients. So the rate that expresses this reaction is given by K, which is the rate constant, times the concentrations of A and B to their exponents. These exponents, M and N, are dependent on each experiment. They are determined by the experiment. So M and N are exponents that are determined during the experiment, and if changing the concentration has no effect on the rate, then the exponents are 0. If doubling a concentration doubles the rates, then the exponents will then be 1. And finally, if doubling the concentration increases the rate by 4, the exponents will be 2. So here's an example of how you will calculate what M and N exponents are. We're going to start by looking at 3 different experiments, and by comparing the experiments, we can find what these exponents are. So in order to compare experiments, one of the reactants has to stay the same while the other one changes. So to find the rate of dependence on A, we can use experiment. So here we're going to be looking for an experiment where only A changes and B stays the same. And in this example, we can see that A doubles while B stays the same. So we can use experiment 1 and 2. So the concentration of A doubles, and the rate goes from 0.005 to 0.01. So we can see that the rate also doubles. So since A doubles and the rate doubles, we will say that M is equal to 1. So to find the rate, which depends on B, we can use experiments. So let's look. Where does B change? So it looks like it changes going from 1 to 3, and A stays the same at 1 and 3. So we can say that experiment 1 and 3, we can compare there and determine what the exponent is. So we can see that B doubles, and the rate goes from 0.005 to 0.02. So this is like multiplying this rate by 4 in order to get to experiment 3. So if you remember the rules, if the concentration doubles and the rate increases by 4, then N would equal to 2. So our final rate would be A is to the 1, B is to the 2nd power.